Hello my friends, welcome to Code Guy channel. This is video about how to implement the shortest path algorithm. In this workshop we need to write a function that will look for shortest path between the nodes in a graph and also return the path taken. For the first step we need to define a variable named I and f. This variable will have a value of float I and f that will be represented as a positive infinity number. Step number 2, we need to create ADG matrix variable. This variable will be assigned to the list that will consist a 2D adjacency matrix of the graph. On step 3, we need to define function shortest path. The function will take 3 parameters. First, matrix, second, start node, and target node. That is, by default, will be assigned to the none. If the target node will be not specified, it means that we need to build the shortest path from the starting node to the all other nodes in the graph. Step 4, we need to create variable that will store the length of adjacency matrix. Step 5, create distance variable and assign it to the list that for now will contain only one element I and f. In the future, it will contain all the distances from the start node to every other node in the graph. Step 6. The length of our distance list is supposed to be equal our adjacency matrix, so we need to multiply it by n. Step number 7. After we initialize distances list, we need to update distance to the start node, and it will be always 0 because we haven't moved anywhere else yet. Step number 8. Here we need to define paths variable that will be assigned to the list. This list will contain paths that have been taken to reach each node. To do this, we will use the list comprehension syntaxes. Node no for node no in range n. Step 9. To know which nodes we already visited, we will define variable. They also say that we need to initialize this visited variable with false for every node. We already did something similar with distances variable. Let's multiply a list containing false value by n. Step 10. To update distances and paths over multiple passes, we need to create for loop. It will look like this, for underscore in range n. We wrote underscore because we are not going to use the iteration variable. In the body of the for loop, we need to define 2 variables. Mean distance equals I and f to hold the smallest value found so far in the current iteration, and the variable current assigned to -1. This variable will store the index of the node that has this smallest distance. Step 11. Inside the first for loop, we need to create a second for loop to check every node to find the one with smallest known distance. Here we are iterating through each node node in the range of n. In the body of for loop, we are adding paths for now. Step 12. We need to decide if the node we are looking on is better than we already chose. In second for loop, put if statement. The if statement will check for 2 conditions. First, we need to know if we visited this node already and if the distance is less than mean distance. Inside the if statement, add path as a placeholder. Step 13. If both conditions of our if statement are true, then we need to update the mean distance to distance node and current node to node node because we found the best option. Step 14. On the top we have the loop that checks the nearest unvisited node. If we found any, then variable current will have its index value. If we didn't find any, then current will stay -1. Here we are writing the statement if current equals -1, then we stop the loop with break statement. Step 15. If the valid node has been found, then we have to check it as visited. Then we don't have to consider it in the next iterations. Assign to true visited node with index current. Step 16. Create another for loop for node no in range n distance assigned to matrix current node no. We need this loop to look through all the neighbors of the selected node. Step 17. Create if statement to verify that neighbor is reachable and unvisited. If distance not equal I and f and node is not visited, new distance assigned to distance current plus distance. where is distance current is shortest distance to the current node, and distance is the distance from the current node to the neighbor. Step 18. In this step, we are checking if the distance that we just calculated in previous step is better than we are storing in the distance list. If new distance is less than distance not known, new distance should be assigned to the distance not known. Step 19. When you find the shortest path to a node, you also need to update the actual path taken to reach it. Nodes not known assigned to paths current plus not known. Step 20. Once the algorithm has finished running, you need to decide which nodes is display results for. Assign targets to if-else statement. Targets will have a value target node list if target node is not known, else it will be assigned to the range n. Step 21. After we decided which nodes we want to display, we need to iterate through them for not known in targets in the body of the for loop would pass. Step 22. In this step, we need to display results for nodes that are not start node and reachable from it. Here we are creating if statement if not known is a start node or distance to not known is INF, then we need to continue, that we need to skip the step. Step 23. After we figured out which paths to display, we need to print them. In this step, we need to use a generator expression. Define variable string path equals to string n for n in paths not known. Step 24. We need to use the join method to combine string representations. Variable paths assigned to the string space arrow space join method string path. Step 25. We need to print result to the current node. Add the print statement with f-string. Replace starting node with start node, not number with not known, distances with distances not known, and path with path. Step 26. Return distances and paths. And finally, step 27. We need to call function shortest path. It will accept three parameters. First will be edge matrix that we define in the very beginning. Start node will be equal 0 and target node 5. The algorithm is completed. Thank you for watching. See you next time. Bye bye.